Hello students, my name is Sibal Talichani. I'm an assistant professor in the Department of Electro-Optical Engineering, National Taipei University of Technology. So today I will teach you the course Machine Learning for Optoelectronics Applications. First I will try to start from the introduction part. So in this course I will try to highlight about all the course overviews about this course is like the first one is to understand the basic concept of machine learning and apply them for the various problems. So there is different concept of machine learning and we'll try to highlight about that one. In addition with this one, to learn various machine learning types and use it for the various machine learning tasks. So there are different type of machine learning algorithms, and then we try to see that how we use these machine learning algorithms in different tasks. And then also from this type of different machine learning algorithms, there are different type of classification and regression models or algorithms, and we can see and compare how the difference and then how the application on that one. So depends on our times also, we try to highlight about the application of the machine learning and optoelectronic applications because the main focus of this one, this course is mainly more focused on the machine learning for optoelectronic applications. So finally we try to highlight about how machine learning can be applied in different optoelectronic applications. So let's start from the beginning. So first let's see about what is the machine learning. So the introduction parts. So when we see about what is machine learning is a field of study that gives the computer the ability to learn without being explicitly programmed. So this is the way how we say that machine learning, or in general, is learning. That means the computer by itself can be learn without the intervention of the human beings or without being explicitly programmed according to the author Samuels that's defined by this one. So from the concept machine learning, when we see about what is learning specifically, so this learning any process by which the system improves the performance from the experience. So this machine learning means like human beings, like it learns from different experience from the data or from the environment. So the basic difference between the learning and the machine learning is when we come to in the learning, like this learning is acquiring skills with experience, the accumulation from the observations. So that means there is an observation, this observation is like learning, and finally we can get the skill. This is in general in learning. So when we say that learning, acquiring skills with experience from the observations. So like it's observed from the environment or from the other areas, and this observation like accumulated and learning, and finally we can get skills. When it comes to in the machine learning is the acquiring skills with experience, which is accumulated from the data. That is the difference. So when we come to in the machine learning, more focus on the based on the data. So that is the computer or the machine is learning from the data. So the data is input into the machine learning algorithm, and the machine learning algorithm learns from the data, and finally that model or the machine learning algorithms have the skill. So this is the way. When we say that machine learning is actually that is the way, like the machine can learn the skills from the data and also from the observation. That is the way in total machine learning is the ability to learn from the data or from the observation. When we see that the basic definition of what is machine learning also, so this machine learning is a subset of artificial intelligence which focuses on methods that allow computers to learn from the data and past experience on their own. So the basic thing is when it comes to in the machine learning is the data or the computer or the model is learn from the data and the past experience. So for example, if we want to learn about some of the data that's generated from the experiment, and then we can give that data to the model, and the model try to understand that data and then learns from the data and understand about the futures. And also it's like past experience, learn from past experience. That is the general definition of the machine learning. So when we say that learning is like, because computers is given and it's an initial pattern recognition models and some data and figures how to make the models more better. So just through learning with a lot of times, or through, like for example, for a long times, that means the models is become more better experienced and have the better generalization performance. When we come to the machine, the concept machine, because the computer learns automatically, so without the intervention of the human beings, that the computers can learn from the data or from the past experience. That is the way the concept learning and the machine that connects with this one, and we can get that the concept how machine learning can help us to improve in different tasks to learn that one. So because of this one, the concept machine learning in general is improving some performance measures with experience computed from the data. For example, this figure, it showed that the communication, like the human, for example, it said that I can learn everything automatically from experience. So can you learn it? So human beings in general, like for example, they learn from the experience or learn from the friends or from the family, from the environment. Also machines can learn. Yes, I can also learn from the past data with the help of the machine learning. So we can teach the machine using the data. The data may be like historical data, experimental data, or using maybe the data is like type of numerical data, maybe image data, maybe text data, or like video, or different type of data nature. So using this one, we can teach the machine learnings. The next concept is like the machine learning algorithms. So when we say that the machine learning algorithms, which is an algorithm that is able to learn from the data. So, but what do we mean by learning? Just when we say that machine learning, specifically the learning, what do we mean by the learning? So when we say that learning is the computer program that's said to learn from the experience with respect to some class of the tasks and the performance measure with P. So learning is like the connection between like experience, the task, and the performance measures. That means it is performance at task T as measured by P, or performance improves with the experience. So when you see that the concept of the machine learning, that means a computer is like learn from the past experience, and then with respect to, or in order to perform different tasks T. So the task may be like there are different type of tasks. Maybe like is classification, or maybe it's regression, or maybe image recognition, or like any other type of task, that task. And finally, the performance of that model in the algorithms will be measured by using the performance measures P. So the performance measure P means the way, the mechanism that we evaluate the performance of our algorithm. So finally that one. So that is the way the concept the learning can be expressed by using these three terms, that is A, P, and then T, three terms. So one can imagine a wide variety of experience and the wide variety of tasks and the performance measures. So in the next few slides, we can try to see that the detail about how this the connection between the experience, the task, and the performance. First, let's see about what is task T in the learning process. So task T, or T means actually it enables tackling the tasks too difficult to solve with the fixed programs written and designed by human beings. So this task, when we can say that the machine learning is interesting because developing machine learning initials understanding the principles and the underlying intelligences. So in order to solve these different tasks, the machine learning is like just designed and developed to understand the principles, the features, and the patterns to solve that tasks or in order to solve different problems. So just this one, when we say that process of learning itself is not the task, but in order to say the task, learning is the means of attaining ability to perform the task. So in order to attain that tasks, learn from different experience or from the data or from the observation or from that one. That means if we want to, like for example, a robot to be able to work, then working is the task, the one task. So just in order to make that one, the robot to become work, we should be learn about how to work, the movement, the direction, and we should be show that how to work that one before just the final output. So the way to teach the robot how to work from one place into another is the way the procedure, that is, we call it learning. Another example is, for example, we could either program the robot to learn to work, or we could directly write a program manually for the working. So in order to teach that one, the robot is learning to work, or that just program manually for how to work that one. This is the way, the principle that we call it task in the learning process. For example, this one is some kind of tasks solved using the machine learning algorithm. For example, is classification. The one is also the common tasks that we use in different applications. Let's say, for example, we can say that in order to classify the email as spam and not spam, or we can classify, for example, different objects like maybe animal or a table, and like this type of tasks. Is the other one is classification with the missing inputs. Then classification with missing inputs means, for example, we have a data, have just some of the data have the missing input, and the other one is maybe a normal one. So in order to classify that, the data between the missing inputs and the normal one is a classification. And regression, and also the one tasks, maybe actually we can see in detail about this one in the next maybe chapters or PPTs. And transcription, machine translation, structured output, anomaly detection, denoising, and density estimation. All this one is a different task that performed by the machine learning modules through the based on the experience. And then finally, the performance of these tasks is measured by the performance measures, or P. The other concept in the learning process is the experience. So this experience is broadly categorized as the supervised or unsupervised one. This is the way or the mechanism that the machine learning can learn from this one. So based on what kind of experience they are allowed to have during the learning process, this experience can learn maybe either like supervised or unsupervised one. So this is, it depends on the problem and the data natures. So this is also the type of the machine learning algorithms, just because this one the introduction, and then we can see in detail about what is supervised learning and what is supervised learnings within the slides coming through the next one. So when we say that just experience, actually most algorithms experience is from the data sets. So also called, like we can say that, the data points. So the algorithm and the model can get an experience from the data or data points. This is the concept how the machine learning in general is defined by that one. So for example, in order to define the learning tasks in general, what is the learning one, we can see that some of the example that show that how this learning process improves on the task T with the respect of performance meter P, and based on the experience A. Let's say, for example, the first one is an example that spam email detections. So when we develop the model that detect or classify the emails like as spam or not spam, for this the concept, the task is just classify emails as spam or not spam. So this is in the learning process. When you say that task means actually our goal to solve by using that algorithms. And then experience means actually this watch the user label email as spam or not spam. So from the for example, when someone is labeling that data as email and not spam, we can get experience how we can say that which type of email is we can say spam and which type of email is we can say that not spam. So from that one we can get an experience from the user how to label the emails. And then P indicating the percentage of email messages correctly classified. So finally, for example, let's say the model is already developed and we give an email data. That email data is classified maybe as spam or not spam. But in order to generalize that our model is good, we should be measure the accuracy or the performance. So that performance measurement technique is we can say that the percentage of the emails message which is either correctly classified or incorrectly classified. That is the performance measures. Also, for example, if we want to develop like the model that for playing the game in the checkers, so the task is like playing checkers, and the performance is the percentage of the game won against an arbitrary opponent. So the percentage or performance is actually just based on the win of the game from the opponent. So that is the percentage of the game. That means, for example, if I win like 50% or 60%, that means our performance may be good. And then if the opponent is maybe like more than our, that means the opponent is have a better performance. And the experience like playing practice games against itself, so it just is learning from that experience. This is the way how to define like learning tasks. So just when you say that in the machine learning, this is the process that learn from through experience by using the data in the data sets. And also the others just also mention about the way how to define that one, almost the same concepts, maybe just read from the PPTs. So in order to differentiate the difference between traditional programming and machine learning, the basic difference is like in traditional programming, just we have a data and then we should program that data and finally we can get output. So we need to program. We need to manually maybe type the code to get the outputs. But in the machine learning concept, like the data and we have an output or which is actually the expected output, or that's called, we can say that sometimes the target one, and then that data is like used as a program. So the basic difference on this one is, for example, in traditional programming, like input plus program is output, but in machine learning, just input plus output is the program. So the input means the features and the data, and the output means the expected output can be used as the label data or the target data. So combining it to this one, we just develop the model. That model is, we can say that, the program. So the other difference, the big difference between traditional programming and machine learning is, in traditional programming, well-defined requirements. So we should be well-defined, the specific ones. But in the machine learning concepts, requirements keep changing all the time. We can update, we can tune, we can also change through the times in order to improve the performance. So it's not like the well-defined, not fixed programs when we come to in the machine learning, but in traditional programming, it's like type of static one. So once the program is defined, that the task is mainly or specifically working on that one. For example, like in traditional programming, like type of rule-based execution, just follow the rules. That means mostly like it's type of static one. But in the machine learning, the program learns from the patterns and change decisions and outputs through time. Because of it learn from the pattern, so by tuning or changing different parameters, we can still change the way how the model can learn from the patterns and the outputs. So as an example, like in the machine learning algorithm, we use just a lot of open source libraries. For example, we can say that like different libraries from the by using maybe it's like Python, actually the most common one. So in Python there are different open source libraries, so using that libraries we can just create the program. So like for example like anomaly detection, so in order to detect anomalies from the data, just we can program that one, but through the times we can tune and then change all the parameters until we get that the best performance. Next, let's say about why or when do we use the machine learning algorithms, or maybe when machine learning is maybe more important. So machine learning is more important, especially when human expertise does not exist. For example, navigating on the Mars. So in the Mars, maybe like human beings, it's difficult to go there and maybe analyze like something. So instead of like in that places, maybe like machine learning is the method that covers the human being tasks. That means humans expertise maybe does not exist there. So instead of that one, we can use different models to analyze the data, the environment, or the task that happen on there. So this is the one way. Another one, maybe when the machine learning can be more important is humans cannot explain their expertise or the solutions easily. For example, in speech recognition, maybe human beings cannot understand that speech, so the machine learning is more understand that speech is like more than the human. So at this time, maybe machine learning is like more important than the human beings, especially in speech recognition. Sometimes maybe due to the language problems or like the pronunciation, maybe we cannot understand the language, but when we come in the machine learning algorithm, that's more understand every features more than the humans. The other one that's the machine may be necessary is when the model must be customized. Like for example, when that model must be like customized or tuned or modified every times, that maybe the models can be more important. For example, in the personalized medicine, system, for example, let's say that we can develop the personalized medicine systems. So the personalized medicine systems may be changed due to like in different type of like patients. So that medicine may be different through time to time. Like maybe today is different disease and next time is different one. So depends on the disease, the medicine is also like different. So that means it needs to customize every time. So in that type of situations, the model must be customized. So and for that type of tasks, machine learning is more important. But the other one, we're needing rapid decisions that humans cannot do. Maybe sometimes actually we need to decide firstly, but this decision may be more difficult to human beings, like for example in the high frequency trading. So recently there is a different type of online trading. So in that type, maybe human beings didn't understand that trading, but the machine can easily understand that way and then makes like the rapid decision. So for that type of tasks, the machine learning is more important and the model is more important. The other concept is the models are based on huge amount of data. Specifically, this one also the most important problem right now in the real environments actually, especially when the number of the data is huge, is very difficult to process that data by using human beings. So when the amount of the data can be huge, it's like because of difficult to process that data using human beings, using models and machine learning algorithms is more easier, and because the machine can like analyze that data within like short times. So because of that one, when the huge amount of data is there, it's better to use the models maybe to analyze that data, to just generalize that data, and to predict that data, and for the different applications. So for this type of problems, the machine learning is maybe outperform than human beings. Actually, still now, human beings is better in some conditions like the machine learning, but in some conditions the machine learning models outperform that the human beings. So this is the basic applications that specifically important where machine learning can be applied throughout the real environments. So just from that concept, we can say that the basic importance of the machine learning is develop systems that can automatically adapt and customize to individual users. Yeah, so when we develop the modules, we can develop the system that automatically adapt and customize. For example, we can train the machine now, and then next time if we want to update the data, by updating that data, we can retrain and then update and customize that data by using new data. This is the way. Like human beings, for example, human being actually, when you go somewhere, learn some experience, and next time when you change a place, maybe he can learn also from that place. The same thing when it comes to in the machine learning. Today maybe we can teach the model by using maybe 10 data, and then next time maybe by 100 data and 1,000 data, 10,000 data, and like that on. So when the number of the data can be increased, the model is like the way the learning can be also increased, because it learns from huge data and understands the pattern from that data. That means it's automatically adapt and customize that data. Another one, discover new knowledge from the large database. So when we give for example millions data on 10,000 or 100 1,000 data, then that's the model discover, understands, and knowledge from the databases. And the other one is the ability to mimic humans and replace certain monotonous tasks, which requires some intelligence. So that's right now it's the machine learning can be act as human beings and then replace human beings in different areas. So because of that one, it just makes simplify our tasks and develop systems that are too difficult and expensive to construct manually. So very especially in the difficult and expensive areas, in order to just save the time, the cost, easily we can develop the model, and then we can just perform different tasks. For example, this is the machine learning algorithm, the model. So we have a training data here, and then this is the learning algorithms. The learning algorithm is maybe different machine learning algorithms, and then here there is, you see, there is setting. This setting means we can just change different parameters in the machine learning algorithm. That parameters can be tuned, and then when you change these parameters, the way the learning process is also changed and understand different patterns. And finally, when we get a best performance, we can say that we have a trained machine. So the final one, the best or the optimal models, so we can say the trained machine. We have that one, and after that one, we can ask any queries, or we can input new data to this one, and we can get answer from that one. This is the learning process. So first we should train the model or the algorithm by using a huge amount of data, and based on that data we already have a trained machine. That means the trained machine is already ready to answer the questions that is related to this data. So next time when we have a new data that is related to this one, we can give directly to the trained machine, and the trained machine just give the outputs based on the experience that get from this data. So this is the basic ones. So specifically, for example, this is the one example. That is when we use that, show that why we use the machine learning algorithm. So the one example that's the task that require the machine learning is, it is very hard to say machine what makes two. For example, using this one is optical character recognition. So from this one, maybe it's it's very difficult to identify which digit is indicating two. So maybe human beings may be difficult to identify which one is 2 and which one is 3. So but when we teach the machine, and the model is easily identify that which number is indicating 2. So Commonly, machine learning also the one that is more important in the optical character recognitions to identify different characters. So from this one, the machine can easily identify that which digits can indicate like 2. But just physically, when we say that, when we see these parts, maybe like when human beings, maybe it's like difficult to identify that one, but the machine learning can accurately identify that one just based on the training. This is the one example that showed that how machine learning is like applied in the optical character recognition tasks. Another one, actually there are also the other tasks that when we use the machine learning, some of the examples, for example in the recognizing patterns. Recognizing patterns means like facial identify or facial expression. So by just seeing the face from the humans, just identify that, for example, maybe the emotion from the face, whether he's angry or he happy or sad. So maybe just like we can detect this type of task from the facial expressions. We can classify like that one. Another is like handwritten or spoken words. So just recognizing the handwritten or the characters, and also the voice recognition or the spoken words. So when I speak like that one, for example, the model can detect what I'm saying, like the character or the topics. And the medical images. Also recently machine learning is highly implemented in the medical areas for recognizing or detecting the medical images, because there is different X-ray images. So we can give that X-ray images and we can teach the model, for example, to identify like which type of disease based on that image, and then we can analyze using like the machine learning algorithms, and then it can be just help the task for the doctors to simplify the decision. Another area that machine learning can highly applicable is like generating patterns, like generating images or motion sequence. So recently actually generative artificial intelligence is the hot topic. That means we can generate different images using like text captions. That means just using text to image or like image to image, and also like the different way of transcriptions or like generating ways. So for example, when we give like some texts, then based on that text we can generate different images and the sequence or motion sequences. That is the mechanism. So this is also the one mechanism. And for example, also like when we come to in the recent like ChatGPT or LLM, large language models, like using these mechanisms, when we give a text, we can generate image or motion sequence. Recognizing anomalies. So when you say that recognizing anomalies means just like, for example, unusual credit card transactions. So when we can collect data that show that the credit card transaction. So from the credit card transaction, the model identifies that which card transaction have maybe the anomalies. So maybe there is a normal one, and also maybe there is some actually a problem on the card credit card transactions. So in order to identify which one is anomaly and which one is normal, is because of like huge data or like that one, we can use also the model just by giving that data as easily identify to the identify the anomalies. In order to predict, like for example, the stock price or currency exchange rates, so maybe like we can give the data maybe like the past few months or weeks, we can train by that one, and based on that past experiences, the model can predict the future stock prices or the currency exchange rates. So this is the way, why and when we use the machine learning algorithms in different tasks. Actually, this is just the type of the tasks. This is not all, just only some of the concepts, and maybe later I will show you like different applications, like more than this one, and we will see that one. Now let's see, for example, the application of the machine learning. One of the application of the machine learning is, for example, recently there is the autonomous car technology. So when you say that autonomous car technology means like the self-drive or like human, just the car actually is like drive by itself. That is the means the car can first we should train that the way. For example, this is the adaptive visions and this is the car. So there is here camera and the lens and understand about the path here. For example, this is the sample, the way the training one. So it showed that this is the car and there is the path planning that learns from the by using this sensor. So based on this one, it understands that where is the curve and how to go, and then when it's just like turn to left and right. So using that conditions, for example, the car automatically learn that one. Let me show one video. This is, for example, the one example that shows that the drive safely along the curving road. This is an example. So it's like the auto one that recognize and then so from this video actually just adjust this, and then after that one the car is by itself, it can be drive by itself. So that is the way actually is just first we should be trained about that one, the different cars. So based on that one, you can automatically go and learn from that one. So it's like recently the auto cars that already implemented, and this is the one, the application of the learn for artificial intelligence, the environments. Okay, another application is the optical character recognition. So, for example, there are different apps that recognize the characters. So, for example, there is a camera scanner, so we can just detect the characters from the texts or from the book or like that one. So, optical character recognition is once we develop the model, just automatically recognize the characters from the different places, like from the table or from the book, or that is the way. For example, let's say the camera scanner, so that's the app or the module, and just automatically recognize the characters. And the machine translation, also the one application, that's just the way or application of the machine learning and learning. That means just translate from one language into another one. Let's say, for example, from Chinese to English or from English to the Chinese. That is the way to translate the language. For example, here the text in English, and finally just translate into the other languages. Another application is speech recognition. Like, for example, this Siri, like just we recognize our voice and then try to give answers. This is also the one application of the machine learning. Credit card fraud detection. So just in the transaction, actually from the transaction, we can just detect that which one is the fraud and which one is the normal. And so maybe if the transaction is not like a real one, so that's help us to detect that one. And maybe it's important to just give a hint that in order to avoid like type of the fraud transactions. And the product recommendation, also like recently YouTube and Amazon, and also like for example Netflix is like using this type of recommendation. For example, when we buy something from online, the next time the product that is related to the previous one is recommended by the YouTube or Amazon or any other type of like websites. And like that one, for example, let's say we can buy some book like this one, and then just it say that customers who bought these items also bought that one. For example, we buy something that's common with my friend, so but my friend just add another things like or buy another things also in addition with that one. That means if we buy something in common, then also it suggests and recommends what what type of thing that our friend maybe bought, and also just recommend a similar product that I already bought on that one. So this is just a product recommendation, like in the movie also, not only in the product. Let's say in YouTube, for example, when we watch some video, and next time maybe we can just see that the video that is more related with the previous one, that is just based on the algorithm. So this is the recommendation of recently. Also Facebook and TikTok algorithm also work like that one. For example, once if we see some like topic, and then next time the majority of the topic is like related with the previous one, because the algorithm just use recommendation techniques. So just like, for example, there is also a suggestion or like a mutual friends. So if once a friend with like someone, that means the friend of that friend is like maybe become as suggested friends. That means this one is like also the application of the machine learning, that's like recommendation. So in Facebook, like TikTok, and any other application like YouTube also use like this type of machine learning algorithms for the recommendation. So another application of the machine learning is in the email classification as spam and not spam. So the email algorithm by itself can classify emails as spam and as not spam. That means based on the received emails and based on the content of the received emails, just automatically classify as not spam and the spam one. So maybe for example, this one is the not spam and this one is the spam email example. So in the spam one, just like the content of the email is including maybe like different unnecessary contents that talk about maybe like a credit card, or that have maybe the hash or dollar signs and like that one. But the normal one is actually just like maybe the content is more clear on the some of the subjects. So for example, in the spam one, it said that say goodbye to debates. Acceptable and secure debates includes all major credit cards, no collateral, bank loan and personal loan, like that one. So maybe if this one is talking about credit card and personal information on back, we are expecting that this email is spam. So the email actually, by considering this type of content, is just automatically input into the spam labeling. So when you see that your email have a labeling of inbox and like draft and then spam. So that spam means indicating that the email algorithm just recognize that email is not important and not secure. So because of that, it's automatically input into the spam folders. So this is also the algorithm of the email that works to classify like the spam and not spam emails. So the goal of this one is just to use emails seen so far to produce code prediction rules for the future data. Another application is the face detection and recognition. So this slide, it showed that, for example, in the face detection, it detected the face of like the woman, the girl and baby and the man. So for example, maybe in different applications, especially in the like, for example, when you just take a money from the ATM card, maybe just face detection is maybe important to just make like secure who can just take the money from the ATM and like that one. So this is the one application. And also the object detections, just detect the different images from different areas. So let's see that there are different images here. So the model can detect what type of images and the object is there. For example, here is a horse, there is a person, there is a car here, and there is also here like the mic. So there are different objects and detect that objects based on their training. Another application is like in sport analytics. So recently, actually, the machine learning and the algorithm is implemented in the sport area to just analyze the sport, or in order to record the statistics. For example, maybe the coverage distance, maybe like the number of attempts, the number of the goal, and just like this is like recently there is a different way or the statistics that just analyze the sport. So in this type also just analyze like the game or the ratio between the opponent and then the two players or like that one related to that one, and analyze the data related to the sport one. This is an example on the, like for example in the image recognition and the classification. So this is the image of the cat, and this image is input into the training model, and the model is just automatically say that this one is the cat or this one is dog. So it depends on the training data. When you give the data or the image into the algorithm or in the machine learning models, and then the machine learning algorithm helps to classify or categorize, this one is a cat or this one is the dog. So this is just the simple model that shows that how to detect or recognize images. This is also the video that showed that how image recognition in the like in somewhere in the road, and there is a different objects there. So when we move different objects, the model can automatically detect or recognize different objects. For example, here it said that a person, and show that the accuracy of the detection. See the car, and there is a person and different objects. So in the movement also, for example, this one, just the model or the machine learning algorithm is connected into the edge devices, and then from the live video we just record and recognize a different objects from the crowded place, for example here, and then analyze that what is this object, and then we can easily identify what type of objects are there in that road. This is an example that showed that like different categorization. For example, it showed that here the labeling, it detect like car, and also show that the accuracy, and like this is also, for example, there is a small car behind there, and because of this car is not fully observable, like it detect accurately as a car, but the accuracy is still like 65%. But here this is a big car, is like is fully observed, and because of that one the accuracy is become 93%. So in different crowded environments also we can use or we can detect the different objects by applying the machine learning models. Another application of machine learning is like voice recognition or speech recognition. So this, it showed that there is a sample of voice recorded here, and we input this recorded voice into the model and the machine learning model, and then finally the model it said that okay, the voice of this voice, it said that hello. So we know that. So for example, sometimes maybe we can not easily understand from the voice, but using these machine learning models we can just get information or an output about what is the voice of this one. It said that is hello. So this is the way also just like a speech recognition. It recognizes the speech of this one and finally display the output.
Let's say you want to ask Google to make you a haircut appointment on Tuesday between 10 and noon. What happens is the Google Assistant makes the call seamlessly in the background for you. So what you're going to hear is the Google Assistant actually calling a real salon to schedule the appointment for you. Let's listen.
So no problem, I will make you like that one. And also there is just like a conversation between the Google and also the expert system, and then when the user can ask something, it automatically detect and understand the language and then replay a response for that one. That's when like
sure, what time are you looking for around?
And this is a machine translation. Machine translation means actually just language translation, so it translates from one language into another. For instance, there is like Google Translator right now. So when you give like English to Chinese or Chinese to English, like when you say that how are you, and then when you give this to the model, like for example Google Translator is, we can act as a model and then automatically translate it into another language that as we want. For example, maybe we translate into French or Chinese or like in any other language. So recently, like because of this machine translation, it can be make more easy to understand different languages and easily just make a communication between two different peoples. So that is the one application of machine learning that makes more easier for the communication, because even if we cannot speak that language, we can use these translators and translate from one language into another one. Another application is a conversational agent or chatbot. So this chatbot or conversational agent is like an expert system. It can be like act as a human being. That means when someone is asked a question, that agent or chatbot can reply an answer for that questions. That's called a chatbot. Recently, actually, ChatGPT is a type of chatbot that's replace an answer for every question from the users. And also some organizations actually can integrate different chatbots from the website, and then when we open the website, there is a pop-up menu that just receive questions from the user, and when the user just like writes something, and when it sends it, the ChatGPT or the expert system can automatically replay an answer for that questions. That's called like chatbot. For example, here it shows that the user can ask that, how are you, and then just input into the model or the chatbot, and then that chatbot or the model reply that I am fine and thank you. So it's like act as like human being and reply for the user questions. This is also the one application of machine learning recently that's widely implemented in different areas. So this showed that actually there are different tasks here, like image recognition, machine translation, voice recognition. Is this type of data is together input into the model and then identify that for each task. The one is like image detection, machine translation or language translation, and then also for the voice or the chatbot. So this all is like the way how we can implement machine learning in different applications. This is actually, we already see that the way how like machine learning also apply for the drive safely along the curving road. So it's like understand and learning from this one, from the experience. So first actually the humans can train the machine or the car how to just like drive, how to turn in the curve and for the speed, and finally after training they can try to just go by self. That's called like the example of like this drive safety or like auto cars recently can be just go by itself or analyzing different things from the environment.
百度在18年前创业，
Translation, we already see that this one actually in the previous slides, but this is an example that showed that the translation from the Chinese to the English one. So when we input the
AI
Chinese
对于社会
character
的
here,
影
it
响
just
将远远超
automatically
过互
display
联网。
the
过去
English
的20 年，
characters. So
我
this
们
is
都感
also
受
the
到了
one
互联网
applications. Okay, so in the previous slides, we try to highlight that, or we try to see that the introduction of the machine learning. So we try to see in that machine learning, the introduction about machine learning and definition about machine learning and what is learning, just the concept on that one. So we say that machine learning is the way to try to learn from the past experience or from the data. And based on that one, it just try to generalize and perform a different tasks. That is the way the machine learning in general. So in the machine learning, there is we already see that different concepts, like there is a task, the experience, and the performance measures. We see this type of concept. So when we say that task, actually just the goal that we need to solve. That's called, we say that, the task. And the experience means in order to solve that problem, or in order to achieve that goal, we should first we should see some experience from maybe from the real environment or from the previous data. That's called like the experience. Finally, in order to determine that whether our model achieves our goal or not, we use a different performance measure matrix. That's called the performance matrix. So machine learning is like defined with these three type of terms, and we already see this one. And then finally we try to see about different application of machine learnings. So I hope that you will get some idea about the introduction of the machine learning and then some of the applications. In the next chapter, we try to see that the machine learning frameworks and then how to design like the machine learning algorithms. So this is a slide like more focused on how like the structure of the machine learning framework looks like that one, in order to predict or in order to classify some of the data. So this shows that the framework of the machine learning is like defined by this type of equations. For example, y is equal to f of x. So y is defined that the output, and f is like define the prediction function. X is like define the image features. So this x is not only like images, but this data is maybe like text data, image data, video data, and voice data, and any type of data. So when we give this type of f of x, then the output can be determined or given for the y. Here, let's say for example that the training data means this x. So given a training set of labeled examples, labeled means actually just like there is x or input features, and there is expected outputs here. So x1 and y1, and there is xn and y1. This is a like number of data can be defined there. So x represent the input features and y is represent like the expected output from this one. That means when we give x to the model or for the function, prediction function, and then the model expected to predict these results or y1. So given this type of labeling examples, estimate the prediction function f by minimizing the prediction error on the training set. So just our goal is always when we train the model, our goal should be minimize the prediction errors. So the performance should be measured by using like the prediction error. The prediction error should be minimized or low, or that means the accuracy should be high. Testing, apply f to a never before seen test example x, and the output the predicted value y is equal to f of x. This is the structure that define about like the training and the testing. So there is y and then f of x. That means this is the just when once the data is training, the next one is in order to test the model, we should use testing data. For example, like apply a prediction function to future representation of the image to get the desired output. Let's say f of this image, the output is, let's say that apple. F of this image, the output is tomato. F of this image is represent the cow. So this is like we say that the image or the data. So based on the image, the model can easily detect that the image, what type of fruit is there or what type of animal is this. So this is the framework or the structure of the algorithms. So in order to define, this is the steps that show that the general framework of the machine learning algorithm. For example, here there are different type of training data or training images here. There are different animals and different fruits here, for example. And then this is the training data and the image features. So there are different image features here. And then we train this, the algorithm. Let's say we have an algorithm. So this algorithm is like, in addition with this one actually, also we are giving to the training labels. training labels means, for example, this one is like the vegetables and then the animals here. So we need to define that. First, in the training, we need to define the future order training label for this one. Let's say, for example, this one is like a fruit. We say that if this one is apple, we can give in the side like this one is apple. And for the animal also, first we should define that for each images, we should also define that the training labels. And then that means the machine can understand or learn that if this type of fruit, the output is apple maybe. If this type of animal, the output is the cow, or like this. And then finally we have a learning models, because already it's like learning from these futures. And if we want to test the data, say for example, we already trained this one using this data to our models, and then if we want to test our models, we can give just one simple image to this one and the same procedure, and we have this learning model. This image is given into this learning models, and then we have a prediction that showed that what is the name of these test images. This is the way, actually, just the structure, how it looks like the framework of the machine learning algorithms. Let's say, for example, this is also an example of machine learning. Actually, it's like this slide is adapted from the Professor Lee. So this is different data, a large amount of audio data. So this data just train this, we say that this one is the machine. So we train this one, and then this one is called the labeling. This one is the voice, and this voice means goodbye. This is the voice, and this one is, it said that the labeling, which means how are you. And if the voice is like this one, which means hi. So there is voice here, and also there is a labeling one. That means X and Y. X represent the input features, and Y is the labeling. That means finally, after training this one, for example, if we want to test this model, this image, these voices input into the machine, and finally say that you said hello, because we already trained that the different type of voices, and then the labeling. And then finally, maybe next time, in order to test that, when we have some voice, we give that voice into the machine, and the machine is say that you said hello. So this is the testing mechanisms. This is the structure that showed that the machine learning algorithms. This is also like the same example within the large amount of images of different animals. This showed that dog, this showed that cat, and this one is monkey. We're already labeling this one. And finally, we want to give this one in order to predict which type of animal is this one. So first, we train the machine by using this type of data. We already teach the model like this. If this type of animal, you can say dog. If this type of animal, cat. If this type of animal, monkey. And finally, in order to test our model whether he learned a lot or not, or whether he learned accurately or not, we want to test by using this one. Then just we give this image into the machine, and the machine said that this is a cat. So that means it showed that the model is accurately detect or classify this image. So from this experience, you already recognize that if this type of image is a cat, so this one is more similar to this one. Because of this one, the model or the machine can detect or identify that this one is the cat. So this is the procedure that how the machine learning can be works, or the framework can be work. So this is just the same one. Means that, for example, this just the function of the image. We can say that how are you, and f of this one is cat, f of this data is like, for example, in the game one, f of high is like hello. So just in the framework we can give there is a function plus the data, and then we can just display, or the machine automatically display the output result that show that is called the machine learning framework. So in this case, for example, for speech recognition, there is a function or the model. This function is represent the model, and this model received this one, and he understand that based on these voices, he recognize that okay, this voice is it said that how are you. And in the other case, for image recognition, there is a model. This model receives this image and understand that. Finally, he said that the model displayed the output, this image is a cat, like that one. So this is the framework how machine learning can be works. So just if we see how the machine learning framework looks like that one. In the next slide, we try to see that different machine learning types. So we know that there are different type of machine learnings. So these machine learning types can be categorized in depends on like the problem or the data natures. So we will see about the detail on the machine learning types. So in general, machine learning pipeline. In machine learning, there are different procedures in order to determine which type of machine learning algorithm we use for our problem. So to determine that one, we need to follow some steps to determine that which algorithm is more specifically used for our problem or our task. So the some of the procedure that's to determine our algorithm type is, the first one is we first define a clear problem statement we want to solve using the machine learning. So for example, let's say we are a researcher in the field of optoelectronics or in the other one. So the first one is we should be identify that the problem that we need to solve by using the machine learnings. So we first define a clear problem statement, like maybe in the sensor, maybe just we want to analyze the sensor data, so we need to identify that what type of problem that we need to solve by using the machine learning algorithm. So the first step is you should be identify the problem. Once the problem is defined, the next step is we try to find and create the data set. So the next step is just when the problem is stated, the next one is just create the data set to solve that the problem statements. So that data is like collected by using simulation or experimental or from the online sources. So that is, we make it like ready for that data. And then the next step is after finalizing the data set, we pick an appropriate machine learning algorithm to solve the problem statement. So this is the step that you need to identify which type of machine learning algorithm is fit for our problems. So recently, actually, there are different number of machine learning algorithms in these days, and the choice and the performance of this algorithm is vary depending on the available data and the nature of the problem statement. So when we select the type of the machine learning algorithm, mainly it depends on our data nature and the nature of the problem, because the data nature can determine that whether this algorithm is type of supervised or unsupervised, or that type of reinforcement and like that one. Also, the nature of the problem is like determines which type of algorithms should I use to solve our problems. This is also the basic steps that we need to follow in order to determine before choosing the algorithms. So based on that criteria, machine learning involves finding connection and correlation between input and output data actually. And then depends on the data natures and the problems, machine learning problems can be divided into 4 categories. This one is based on the problems. Based on the problem, like based on the selected problem, the can be divided into 4 categories. Based on the input data type used to train the algorithms. So once the data is collected, based on the data nature of that input data type, we can divide the machine learning algorithm into 4 different types. The first one is supervised learning, the second one is unsupervised learning, the third one is semi-supervised learning, and the fourth one is reinforcement learning. These 4 algorithms have a different function, it depends on the data. So first let's see about what is supervised learning. So supervised learning is the most common type of the algorithm or machine learning algorithm. Supervised learning means the data and the corresponding labels are given. So that means if we want to decide that using a supervised learning, that means our data should have an input features and then the output labels, because supervised learning always using labeling data. That means data and corresponding labels are given, means learning with a labeled data or ground truth. For example, this type of structure, there is X input and then Y, that's called labeling. That is, so the data is the correspond of input features and the expected outputs or targets, and X2, Y2, Xn, Y1. This represented like labeling. That means each input data have unexpected target outputs. Supervised learning involves having input variable X and an output variable Y to learn the relationship between the input and the output samples. So because of we are giving the input features and the expected outputs, the machine learning algorithms can understand the relationship between the input and the output from that data natures and easily understand that how the relationship between the data. So based on this one, just the model is developed, that's called a learn function or a framework f of x to predict y given x. So in the model we can give just x and finally we can get the y. This is an example. For example, in supervised learning there is an input and there is a function f like this one, and the output is also known. So this one, it showed that in supervised learning the input is known, just the function in the algorithm still unknown, but the output is also known. That's called labeled data. That means the data nature should be data pre-processed like this type of things. So let's say, for example, in order to just predict or classify temperature data. So first, in order to train the machine, we should have the data that shows the temperature. Like for example, today we need a data and we should show that the actual temperature of the today, like yesterday, or like the before, like 10 days or like more than that one. So that data, it shows that the exact temperature values of each days. So that temperature value may be like the expected output and the machine learn from that one. So that is why here the input and the output data is known one. The main objective, given a set of historical or inputs predict an output. This is, for example, an example of the supervised learning. This is the data, for example, labeled data or different shape of the data. And the labeling, this is just represent as X, the labeling or input data or futures, and this is the labels or like the expected outputs. So this one means it just we already defined that if the shape is like this one, the name is rectangle. If the shape is like this one, the name is circle. If the shape is like this one, it's triangle. So from all this shape is defined like this one, and if the shape is like this one, is hexagon. So the input data into the machine or the algorithm includes both the input features and the labels. So this is the algorithm, machine learning algorithm, and then there is a machine learning model here. Then we already trained the machine based on this data, and finally the model just say that this one is a triangle and this one is a circle. Once the model is trained well and then accurately, like for example, it's like we say that already this one is triangle and this type of shape is circle. So this result showed that the model is accurately predict each shapes. So next time, just for example, this is a test data. This data is input into the machine learning model that already well trained by using this data. So once we test this one, the test data is only includes the label data, not the labels. Only, for example, in this data, in the training data, there is a shape as well as the name of the shape. But in the test data, only shape is input into the model. And finally, there is the output results here. That's called like supervised learning. So when you say that supervised learning, the data nature should be, or our data should have both the input features and the output values or the expected outputs. So in our data nature, if we know that the expected outputs, maybe the type of the algorithm that we need to select should be supervised algorithm or supervised learnings. Given a set of input data and correct, for example, this is the an example that showed that how the supervised learning data looks like that one, or how to pre-process like that one. For example, given a set of input data and the correct answers. Let's say, for example, the goal is find a model that fits to this data, given a house size and number of rooms, and then finally predict the house price. So our data, our training data, looks like this one. So there is house size here, and there is a room size here, and there is a price of the home here. So that means the price depends on the predict the house price. So we need to predict the house price based on what? The house size and the room size. That means if the house size is 80 and the room size is 4, we just say that the price is expected around 220. And if the house size is like this one and the room size is like this one, the price is like vary here. So it showed that we already know that different feature of the house size and room size, and also we know that they expected the price here. So in the training set there is the structure like this one, x1, y1, x2, y2. So x1 represent this one, and y1 and y2 is like from this one, and x2 represent this one, and y2 represent from this one. So the combination of this one, which one say that a leveling data, or which is supervised learning data. So what is the ground truth or the expected output? So finally, in the next time, for example, just we can give the house size and the room size, and then the machine learning algorithm or the model just predicts the price of the house. So this is the price is just the prediction result or the expected output based on this one. So that means the price of the houses depends on the house size and the room size. So every time if we want to determine the price of the house, we should to input house size and room size, and finally we can get the price of the home. So this is just the structure, how supervised learning looks like that one. So there is a training data, and there is a learning algorithms, and we have the model, and finally what? This one is the test data. The test data that include only the house size and the room number, and then the prediction or what is showed that the estimated house price on this. So this training data includes the house size, room number, and price. And then we can pick one learning algorithm or supervised algorithm, and we train that algorithm, and finally we have a trained model. So in order to test the performance, we need to give a new test data like the house size and room number here. Then based on the house size and room number, it estimates the house price, that is y. So this is the structure, how supervised learning can work as like that one. This is an example of the supervised learning, like training data. Is this the image of different animals, and this is the labeling, like it indicates that what is the name of this animals. Like this, it defined like cat is dog, is cat, and like bear and fit to the algorithm. So this is first the data is labeling like this one. There is image and there is also the name of the image, and this algorithm is feeding into the algorithm. You see, this x value and this is y value. So y is like the expected output, but in this case it can be act as also a label data or the expected outputs. So this x for every input features there is also a corresponding target or expected outputs here, and this data all is fed into the supervised algorithm that we need to, that pick for our problem. This is also another example. There is car images here and the labels here. So the sample here that show that a different car, and also we need to label for this one. This is car, this bike, and this bike, and this is just training data set. This training data set is input into the algorithms, and the algorithm is just try to predict like the type of whether this one is a car or the bike. So this is just the data, label data or training data set. So next time if you want to predict, for example, some images or cars or bikes, we need to give like this type of data and train the model, and we need to try to predict. So given a label data set, the task is to devise a function which takes the data set and a new sample and produces an output value. See, so we already trained this one by using this type of data. And finally, for example, in order to test our model, we can give this type of a car, and then we can just know that the model is say that this image is like the car, because just the model understand that this one is more similar to this one instead of this one. So because of that one, just from the experience from this data, it said that this image is like the car. So this is just the way labeling. That is why every training data should be labeling like this one. You see, this one also next, for example, we give already the bus here, but still because this one is more nearest to this one, and still is classified this one as car. Actually, commonly supervised learning is like used for two type of problems, like that's classification and regression. I think so. Maybe this one is the deep concept, so it's better to just continue this one in the on next classes. So I hope that you will get a good information about some introduction parts and then some type of the machine learning algorithms. So we will continue in the next class. Thank you very much.